4, 3, 2, 1. Hello. Tonight we're going to be looking at 0 and negative exponents. If you haven't already, grab out your MJ so that you can follow along with me. Today in class, what you looked at were some of the basic exponential rules, and that we did these two right here. So you should have these already in your notes. If you haven't, go ahead, copy them down now. And that you have any base number that's the same base to an exponent and they're multiplied, you end up just adding the a plus b. So for example, if I have 2 to the 4th times 2 to the 6th, that's going to be the same as 2 to the 10th. Next up is the dividing. Sorry, I need to put a divide sign in there. So if I have a number or a base to a number and the same base to a different number, when you're dividing, you end up just subtracting. So an example would be, how about 3 to the 9th over 3 to the 4th is going to be 3 to the 5th. Okay, so that's nothing new, but I am going to use these as background knowledge or the base for which to learn the next ones. Next up, we are going to look at the 0 exponent rule. Now, you might have worked with this a little bit today, but let me explain why it works and where it's coming from. So we're going to add to our notes is x to the 0, any number to the 0 power. I'm going to use 3 as the example here. So if you take a look at this grid right here, we can see that 3 to the 3rd is 27, 3 squared is 9, 3 to the 1st must be 3, and so 3 to the 0, let's see what that looks like. If you haven't already noticed this pattern to go from here to here, what's that? Oh, very good, that's divided by 3. This one must be divided by 3. And therefore, if we can assume our pattern, which we can, it's going to be divided by 3. Now, the great thing about exponents is that we don't need to use decimals. So if we take a look at this, what would be 3 divided by 3? Well, we know that 3 divided by 3 is going to be 1. Oh, I'll use red. And we're going to use this pattern in the next problem as well. So, and this works for any number. As you work your way on down, the very last one ends up being 1. That's one explanation as to why x to the 0 is always going to be 1. The second explanation down here is the dividing rule. So, using what we already know about the law of division for the exponents, is if I have 4 to the 3rd over 4 to the 3rd is going to be 4 to the 3 minus 3. Remember, any division problems are you subtract the two exponents and you end up with your answer. So if I subtract 3 minus 3, I get 4 to the 0, which if we look at this fraction right here to begin with, 4 to the 3rd is going to be 4 times 4 times 4 over 4 times 4 times 4. Any number over itself, we know, equals 1. Therefore, if we make our way through here, we can assume that 1 is equal to this, is then equal to this, and then is equal to this. So we know that any number to the 0 power is 1. Lastly, we're going to look at negative exponents tonight. So we're going to try to solve what is x to a negative exponent. Let's take the same pattern that we just looked at, and we found that if we went from here to there, divide by 3, there we go, divide by 3, and we got the 1 by dividing by 3. Now last there I mentioned the fraction comment because of this right here. So we can assume that we're going to continually divide by 3. Now, I don't want to put 0.3333333 repeating. 1 divided by 3 is a repeating number. So let's go ahead and keep it as a fraction. So this is simply 1 over 3. Interesting. Which then If I were to divide this, what times what times what goes into 1/3, we get 1 over 9. Now, what this ends up being is 1 over 3 to the first power. 1/9 is the same as, can you get it? 3 to the, what is 9? Right there. As 3 to the second power. So we can get our rule here. You'll notice the exponent is simply flipped up into a fraction, but then it turns into a positive one. So the actual rule is going to be 1 over x to the a. If you start with a fraction, it ends up flipping the fraction upside down, and we'll do some more practicing with that as well. Take a look at this example. Right here, oops, move it up a little bit, is if I have, these two, the second rule here is if you start with 1 over a negative exponent, it actually flips it up, and that ends up being a positive exponent. Reasons for this is, briefly, we just talked about this one is equal to 1 over x to the a, but we still have this fraction. All of that is underneath 1 whole. When you have 1 over a fraction like this, it ends up just bringing this up to the top, which is the same as x to the a. Take a look at this example. So we use our, I have 2 to the 8th, sorry, negative 8th times 2 to the 3rd. We go back to our rules when we have the same bases. That's going to be 2 to the negative 8 plus 3, which is equal to 2 to the negative 5th. Oftentimes you're going to be asked to write without any negative numbers, so that's going to be 1 over 2 to the 5th. Now you could also write that down as 1 over 32. But that's not a huge number. You could leave it either way, but the 2's are fairly simple to write out. There are some example problems on khanacademy.org. Look for exercises, so up in the search bar, if you just type in exponent rules and negative exponents, it will take you to a page that looks similar to this. So up here, if you just wanted to hit exponent, you can kind of see there's these exercises right here. Those are the ones you'd want to look at, the exponent rules and the negative exponents. Those will give you some good problems to practice. With that said, have a great evening.